My name is Karthik Odapalli. I'm a senior solutions architect in AWS, focusing on Amazon.com as a customer. And I have with me today my colleague, Theo Carpenter. He's a senior systems manager in Woot.com. It's a subsidiary owned by Amazon.com. And today, you're in session ANT333, and we're going to be talking about how Woot.com built a serverless data lake with AWS Analytics. If you look at our quick agenda, we're going to do an introduction about what Woot.com does, who they are, what they do, and we look at the problem statement, where did we start from, then look at AWS's solution, or Woot's solution, how we solve the problem together, the architecture diagram. We're going to peel the onion on the architecture diagram, look at the lessons learned, and also talk about the results of the actions that we took. Here are some related breakouts on how some of the other sessions are talking about data lake patterns or analytic stacks. So feel free to take a picture of this slide if you're interested in looking at similar talks or architecture sessions. Awesome. So before I jump into the introduction, how many of you love shopping online? Good deals always make good sense, right? So Woot.com is a subsidiary, Amazon-owned subsidiary, that originated the idea of one deal a day. So it's a small company inside a giant organization. So what makes Woot a bit different is that if you look at the size of the organization, there are very small teams that have org-wide impact. These business teams, business intelligence engineers or systems engineers, the actions and the projects that they work on impact all of Woot's organization. And make no mistake, the Woot exclamation mark on there is not a mistake. It's intentional. Woot is with an exclamation mark. So if you look at the problem statement, Woot had a small team of 4 engineers, and the ability to automate and standardize the data solution was absolutely critical. So automation was required. Next, scaling. If you look at the rate at which Woot.com had growth, exponential growth in the last couple of years, if you look at the number of online shoppers who are looking for smart, intelligent deals online, the size of the data also started growing up. So we also needed a platform or a solution that was scaling with that growth. Now, with data comes reporting. How do we report on the actual data? How do we ensure that we're not looking at false positive? How do we ensure that users or BIEs can modify and act on this data in near real time? And performance. We wanted to have access to data now. How do we, when we have peak events like Black Friday, Cyber Monday, and peak events like that, we need to have access to data at the time of the event. That data an hour later is useless, right? We need to act at the peak of event if needed. So performance was absolutely critical as well. And next, accessibility. To have access to tools that had even simple features like single sign-on or the ability to meet customer expectations, that was absolutely critical. So this was the problem statement. Looking at a legacy solution, I have, I think, 2 stories on that. First, there was a data warehousing engineer in Woot platform. This is when they had the legacy solution. And during one of the Black Friday events, the reports were not being generated. And when people started digging into the code, there were 30,000 lines of code, and this was during the peak event. Obviously, it took time to find the bug, fix it, and there was a lot of backlog of data. So that's one situation that happened with the legacy solution. Now, on the second example, we also had an issue with an Excel formatting that was being reported up the chain. And to fix 2 fields of data, it took about 3 days because of the volume of data that they were gathering. So, as you can see, very silly problems that could have been fixed with modern solutions, but were not fixed. And there was also another fun time where there was an engineer who created an infinite loop on one of the queries in the data warehousing platform. And we all know what happens with that. The system just crashed. So these were some of the problem statements and issues that the customer was facing in the legacy solution. And we also had some key requirements when we wanted to have that evolution in our architecture. First, platform agnostic. Today, we have N formats that we are working with, the happy formats on the cloud, Parquet format, you name it, we all are using them. But in the future, there might be newer formats that we work with, and we don't want to re-architect them. So how do we have a platform that is any data, any source, being compatible in the cloud? Second, resilience. We need to have an architecture that is resilient to peak events like Black Friday, Cyber Monday, or any other peak events that we might have throughout the year. So how do we have a platform where to run a single query doesn't take hours, but a couple of seconds? And next, self-service. When you only have 4 engineers on the team, we would rather have them focus on the business problems and not on giving people access to queries or row-level access or run a query for you for the non-tech folks. We don't want the smart BIEs and engineers to do that. We want to make a self-service model so that people can just consume the data when they want to and keep moving forward. So, coming to the solution, if you look at how the solution was originally built, we look at the Lego blocks that AWS provides us, and we built our solution on top of that. So on the left-hand side, we had the Woot corporate data center, and here we had our legacy SQL servers, our nav services that we call in our corporate data center, and basically all the legacy stuff that we all have, in our baggage. And now on the Woot production VPC, this is where we started using managed services to do the undifferentiated heavy lifting for us. So we started using Lambda, sending the data back and forth from Kinesis. And this was pointing it directly to our data warehousing platform. We also had DynamoDB as our backend for this Lambda. And then RDS was another data source that we used that contained our shipping and tracking information. And EMR platform is what had all of our clickstream data. And obviously Firehose to pipe the data into our data warehousing platform. S3, in the middle, if you look at S3, this was our data lake. This was our landing zone. And we still haven't looked at formation yet. Back then, S3 was our data lake, so it's our landing zone. And this is where all the raw data, the transformed data, the data that we gather from all the external sources, everything sits on this landing zone. Then from here, we use Glue for the ETL process, load the raw data, transform that, add the business logic, add the magic sauce to it, and then put them into the transform buckets so we can use it for reporting, load it into the Amazon Data Warehouse platform, or even give access to third-party vendors so they have access to information on how their products are selling on the website. So now, with that flywheel in place, we were now able to create a self-service model with Glue and S3 for people to self-service from the data that we gathered and analyzed on. And on our data warehousing VPC, we have access to our Redshift cluster, where we have access to all of the transformed data which we loaded from S3 into Redshift. Athena gave access to our engineers or even some of the BIE folks who wanted to run queries on the database or on the data warehousing platform or even on S3 so that they don't have to have a cluster always up and running waiting for queries to come into the infrastructure. They can just log into Athena, run the query, and get the data instantly. So Athena was providing that value for these engineers who did not need a cluster always up and running. Then QuickSight. QuickSight provided that instant connectivity to where the data is already located. QuickSight was able to plug in directly into S3 to look at your raw data, your transform data, everything out of the box. And QuickSight also was able to connect to Redshift to see what kind of queries, how many rows do we have in our Redshift data warehousing platform, and all of those awesome metrics were being gathered in the QuickSight and QuickSight dashboards. And Lambda over here, we were using Lambda here to transform some of the last-minute transformations for folks who wanted to add some more magic sauce on transform data. We always have those last-minute requests on leadership or somebody up the chain asking us, hey, can you do this and get me some fresher data? So that value or that context was added by Lambda, and that's where we added the magic sauce. And Fargate, we use Fargate for some of the tasks to add on top of the data warehousing platform, like if you're looking for not just transformation, but if you add more business logic to it, that was not possible in Redshift. So that's where Fargate came in. Now, if you look at, for the dive deep, I'm going to have Theo come up on stage and peel the onion for you. Oh.
Thank you. Thank you, Karthik. Hello, reInvent. I hope everybody's having a good afternoon. So my name is Theo Carpenter. I'm a systems manager at Woot. I run Woot's DevOps and data engineering teams. Woot is an Amazon subsidiary, as Karthik mentioned, but one of the things that makes us a little different is Everything we do is outside of the Amazon ecosystem, so we act just like any customer. We have our own VPC, we have our own build tooling, we face our own problems, we face the same challenges everyone here does every day. I'm here to talk about a little bit more about the solution that we brought together, dive a little deeper into it. I'm also going to go over what worked well for us and what didn't. So let's dive in. So the first step we had to do to make this system work is we had to migrate our existing data warehouse data. We had to take it from our existing solution and move it onto our new platform. Without moving our existing data, we weren't going to be able to succeed. So what we did and what we found is that we had selected a data lake. So we wanted S3 to be our landing pad. So we took a look at what AWS had to offer, and we found AWS DMS, or Database Migration Service. By using DMS, it gave us a managed service that made it really easy to set up and stream our data essentially into S3. DMS has S3 as a native data destination. By using DMS, it also gave us a solution that was secure. It was in our VPC. And then it also allowed us to easily move to a global service, which was S3, and move between accounts. By moving between accounts, it really fit a good ownership model. We wanted to split our data warehouse out of our monolithic account into a separate account. So what we did is we had DMS set up through some connection string tweaks to point to a S3 account in our new data warehouse account. And then what it also provided was it made it a very efficient process because it brought compressed files over to the other side, which saved us on transaction and storage costs. It also included all the column names. By including all the column names, it made it really easy on the other side to use Glue to infer the schema of what our data looked like, and then immediately begin to access, validate, and compare our data versus our original system so we could have confidence that everything we moved over was correct. So we did a lot of column checks, row count checks, and we were basically able to script whether or not DMS was working. And it was. So after we migrated our original data, we had to figure out how are we going to bring in all of our existing data that comes from all our live services. We essentially had to build a pipeline. We wanted to build one that wasn't reliant upon any particular technology and was going to allow us to scale. So what we did is we took a look at, again, what are our teams using? We're all using the AWS SDK. And as a particular note, Woot actually happens to use .NET, which is a little different from a lot of people, especially at Amazon, which use Java. But the SDK worked for us too. It would also scale to all the other partners and third parties we had to work with that use different technologies. So what we did is, looking at the SDK, we found that we wanted to use Kinesis Firehose. Why Firehose? Well, it gave us a direct put ingestion. So from our code and applications, we could directly put to Kinesis. And then it basically can point directly to S3, which is, again, our landing zone. So by using S3, we also gained availability, scalability, and durability. S3 is some of the most reliable storage out there, and it essentially scales infinitely. And then what it also allowed us to do is, again, we got to separate our account by doing this as well. So we created a data pipeline that our services on the front end send our messages from our microservices into a Firehose. That Firehose then writes to S3. And then we have Lambdas that fire to change, standardize, basically ETL the data. For instance, we made sure everything is in UTC. That was one of our rules. So we have everything transform and change from Central Time Zone, Eastern, Pacific, into UTC. Then we also found we have been considerably investing in DynamoDB. So how does this paradigm and data pipeline fit that? Well, Dynamo has a great thing called Dynamo Streams. They essentially function just like a Kinesis Firehose. So instead of having them go to a landing zone, though, what we did with them, because they're a direct stream, is we went ahead and had Lambdas trigger off of the Dynamo stream. and we just ran the ETL right there, and again, pushed it to S3. So now that we have our existing data, we have our new data coming in through a pipeline. Well, what do we do next? Well, we've got everything in S3. Now we can actually work with the data, which is the really fun part. We can actually start to deliver solutions that help our customers. So what we do is AWS Glue handled the rest of our ETL scheduling. So everything that landed in S3 that didn't need some immediate Lambda type functions, we use Glue to ETL. And then we use Glue crawlers to go ahead and collect the metadata. Crawlers are really the secret sauce here for one of the key items we want to deliver on, which is being platform agnostic. Essentially, what the crawler allows us to do is when developers go ahead and add a new column, or one of our users adds a new column or data type, the crawler goes ahead and just recognizes it and adds it. As long as we're not fundamentally changing our data schema, it just shows up. Before this, what used to happen is every new feature that got developed, it'd get pushed out, and guaranteed a couple days later, report X is broken, report Y is broken, and there aren't as many people on the data team, so now we've got to scramble and do a fire drill to get those reports and data fixed. We've only had, I think, a handful of those since we've done this, where we used to have multiple a month. So it's been a big advantage for us. One of the things we also use Glue for is most of the data coming out of Firehose is JSON-based. We did some testing, and we found Parquet added significant performance enhancement for queries, for query timing. So what we would also do is we transform the data into Parquet for further usability. So this is a final overview of what the solution is, plus a few other items on the user side. So what we did is Kinesis, the highlights there is it's language agnostic. It delivers to S3. Also works just like DynamoDB streams. S3, and I'm going to mention this again because it's critical for what we do. It's high availability, durability, and scalability, as well as global accessibility, means we can use our data anywhere. You no longer have to have a VPC to VPC connection. Your latencies are low. It's a really great product. Lambda is really handy as it is trigger-based and event-based. So we can fire and launch Lambdas based on a number of different criteria. For DMS, it really worked well for database exports that we didn't have to write custom scripts, we didn't have to restore logs, we didn't have to restore databases. And it streamed the changes once it caught up. So it was a really easy solution for us to be able to migrate. With Glue, its ability to handle and move to Parquet is really great. The performance is really fast. It scales up and down really easily without us having to run traditional clusters or database migration tools. It runs as needed. The other thing is it allows us to easily schedule, again, jobs. It has a whole built-in job scheduler, which meant we could schedule when every ETL runs, how often it runs, what the retries were. When we get to the user side, what really helped here is Amazon Athena and QuickSight. Athena made it so our users no longer have to use a database tool, such as MySQL Workbench, SQL Studio. They had a web-based tool. They were able to access it right away. What was really cool about that is it also has saved queries. I don't know how many of you had this before, but prior to this, every query in the company was passed around in text files, in email, in Word documents, and every time it changed, nobody would get the updates. It led to a lot of churn in our reporting. To make it easier for access to, we used AWS Directory Service. We essentially set up single sign-on so that users who are logging in could log in using their same credentials that they use on their laptop. That has increased our database usage and our data usage from about a handful to about a dozen of core users to over 60% of the company. So now we built this cool system, right? But that's neat. But what do we do next with it? We've had it for a little bit. Why was this worth it? Why was the investment great for us? So we evolved. So one of the next things we've recently built off of this that wouldn't have been possible without this type of platform is we built what's called, what we refer to as our gods architecture. And that stands for, depending on who you ask, either Googles of data or good old data service. And through this, Woot is able to query data from any source. We query from, we use EMR, we use Lambda, we use EC2 to hit S3, Redshift, Athena. We can access pretty much any of our data sources through this service. So what does it do? Why is this useful? Well, essentially what we did is we built a deal evaluation service. As Karthik mentioned, we sell things to people. We want to know how to better provide what our customers want. So what this service does is it takes in large amounts of data of possible deals. We join it together with a bunch of different data sets. And then what we do is we process through it. We have 3 different models that we run through it. And they're actually chained together. So the first one does is it does basically an evaluation. It takes a look at what the sales price is, how new the object is it a tier 1 vendor versus someone smaller, and creates a relevancy score. Once we have that relevancy score, we then run it through another machine learning model that goes ahead and calculates the forecast for how much we think it will sell based on that relevancy, depending on our different sales channels. Finally, what it does is it goes ahead and takes those 2 items and creates a cost profitability calculation. With all 3 of those, we do something that used to take our vendor managers a week in a couple hours. And that was for a few 100,000 items. We now run through 4 million items multiple times a week for this. And so one of the things I wanted to talk about that we kind of evolved on that really helped us is in orchestration. So one of the things we have is we have a lot of different data sources, as I've mentioned. We have a lot of different processes, a lot of different ETLs going on. And when we're creating and putting these all together, there's usually no report that runs on one single source being ingested or completed. So what we had to do is we had to come up with a way to orchestrate our jobs and not have some, oh, I think it'll be done at 7 a.m., so I'll run it then. We wanted to get accurate data. We wanted to try and reduce that time and provide accurate data to our customers. So what we have here is essentially what we developed is we take all our jobs, we have a common library, they write to DynamoDB. In Dynamo, it gives you your status of the job, last time it ran, when it ran, and it has basically dependency tags. Then what we have is we have a Lambda that runs every time that table is updated. It goes ahead and looks through and it's like, hey, is this job successful? Cool. If that job is successful, does it have dependency tags? Basically collects all that data together and decides whether or not it should run the next job in the chain. By doing that, we go ahead and then trigger those other jobs. And we also have the jobs run even on a normal schedule as well, just because what if something happens or we miss an update or something like that, it will run at least once a day. But what this goes ahead and does is then we can basically chain all our jobs together. Let me give you an example of how this helped. Last Black Friday, due to high sales, holiday, some large ETL backfills, we had our data running hours behind. But our reports were still sending out. Our customers got inaccurate, incorrect data, and we had to manually run the reports multiple times a day to catch up. There wasn't a good sense of what was going on. By doing this system, this Black Friday, our jobs averaged half an hour late, and that was mainly due to the volume of orders. But every single time that job and report came through, it was 100% accurate. It was a big win for our business users. So what's next at Woot? What do we do next with this lake that we built? What's our next evolution? Well, before we started this, lake formation didn't exist. So we had to build a lot of this infrastructure as code and set up ourselves. So what we want to do is we want to adopt AWS Lake Formation. What it's going to do is it's going to allow us to keep consistency across multiple environments a lot easier. It's also basically going to take our multiple different build pieces for all our kind of functions and areas of ETL and data warehousing and put it into one configuration. We're also excited because it has an ability to be very smart and easy about creating partitions, which have been a pain point for my team. So we're really looking forward to that. The other thing is while our data pipelines bring us transactional data, some of our legacy third-party systems are still batch functioned. So that means we only get data once a day. That's not our goal. We want to get our users their data as soon as possible. So what we're going to do is we're going to basically build a system to get a pub-sub model off of our legacy systems, specifically our financial system, and then be able to put it through our pipeline to be able to go ahead and get that data quicker. We're also going to make more use of views instead of ETLs when possible in Athena. By using views, we're able to rapidly adjust to changes and not have to have something that runs on a schedule every 15 minutes. The view, just every time you query it, it will go ahead and update with the latest data. The other thing is, as I just mentioned in the God service, we are going to expand that quite a bit. We are planning on adding 3 more ML models in the next year. We're going to add one based on search data, so relevancy for how hot an item is or how hot it isn't. We're going to add probably double the number of attributes we're using in it. Then the other thing about it is right now it's a system that just gives you one score at one time. We're going to add a historical tracking system to it, and then also loop that back into our models for relevancy. What does that mean? Well, it takes a while to get a deal, select it, schedule it, get it on the site for customers. We want to basically watch the trend of what happens to that deal over time. Does it have a 10 when you first selected it, but then does it launch with a 5 because competitive pricing or a new product is launched? We're going to bring that in as additional analysis to help our business create better deals for our customers. So, lessons learned. What are some of the highlights we learned outside of this architecture and areas that I want to pass on? One of the first one is aggregation. While we want to keep the raw data, there are points where it doesn't make sense or makes it take a lot longer for you to get your data. So pre-aggregate when you can. Be very smart about it, but pre-aggregate. An example is clickstream data. For our clickstream data, its raw amount in our data warehouse is not very usable due to the sheer volume, billions of clicks a week. So what we do instead is we pre-aggregate some of that, which means we shift a lot less data into our data warehouse. It's about 20 times faster, and it also means we have to store less duplication of data. That's a great one. But now my second point is preserve raw data. So in our system and with a data lake and these processes, you end up with a lot of duplicate data. This is not a transactional database. So you get versions 1 through 50 of a transaction or of an offer. So then you have a lot of raw data to store. What does the raw data do for us? Well, if you have a problem, you can redrive it really easily. You can also very easily determine where your problem was if you have a code change or other issue. And what we've done to reduce that cost is we age everything into Glacier. So we keep our pertinent ETL clean raw data fresh in S3, but then we use Glacier to keep the old ones. Yeah, it's a little slower, but in most cases when we have to pull that data back, it's acceptable. Service limits. There are some interesting service limits we learned about. One of them is in Athena. We had over-partitioned our data, and when you go to query it, you get a number of files error. So you have to balance making small sizes of files that's nimble and partitioned and able to be run versus how wide a query you're going to be. So make sure that you are aware of that. Also, more files means more TPS. More TPS usually means slower. As we all know, larger sets of data blobs and files are faster. And data quality. Well, all of this that in this architecture we built is really cool. Data quality is about 80% of the work. Everything I just showed is about 20%. Data quality, all these tools and everything you build are only going to be as accurate and relevant as the tools, as their data coming in. So if you don't have clean data, you don't parse that data right, it's not going to work out for you. Let me tell you a story a little bit about one of these areas. So Lambda's pretty cool, right? Serverless magic, you can do all kinds of stuff, right? Well, it has a shared pool of concurrency. So your entire account has X number of Lambda jobs that can run per second. We have our data pipelines using it. We have our ETL using it. We have users running some interesting calculation jobs. And a lot of that, as we're ingesting traffic directly from our site, is related directly to user traffic on our website. You might be able to anticipate what happened next, but during a high velocity time, our entire site crashed because we run on Lambda and we ran out of concurrency. So there's something you gotta watch for in that you wanna make sure you use the techniques of pre-aggregation to lower your overall TPS, and then also make sure you're watching for any of those things that are tied directly to user traffic, that you go ahead and put some kind of throttle or alarm on them so that you can be proactive and prevent that from happening and keep bandwidth for your synchronous key tasks. So pain points. Not everything's great. I'd like to say so, but it isn't. So one of the things is visibility. Visibility into some of these serverless systems. You get some logs, you get some metrics, but for instance, when an Athena query fails, it's not gonna tell you. You don't know until it actually fails. What I mean by that is I can't be proactive about it. I can't see that my query's 50% of the max of Athena's runtime or whatever it is, or getting really close on all these various metrics that makes it succeed until it fails. So we basically end up having to file tickets and say, was this a problem? Was this transient? Was it, is our query time growing over time, and that's our issue? It's not very visible. And then for QuickSight, there's a couple problems that have bit us. One of them is there's no default admin role for all of your views, analytics, and dashboards. So what does that mean? If Joe on my team builds a dashboard in a data set, he gets default rights to it. Joe goes on vacation for a week. He's in Europe, doesn't have cell reception. What happens? Nobody on my team can access that data set or a dashboard. We can't change it, we can't fix it. So do we recreate it? Or the other option is we file a ticket to AWS, and yes, they give us access to it, but it's time consuming. The other one is analysis has autosave on by default. Autosave, a lot of people are like, oh, I want to go and see what this different filter looks like or something like that. They're testing it out and they're looking at it. They don't realize they just changed the dashboard for the entire company, and then we get a bunch of tickets saying, all right, where's my data? Why is this wrong? Well, I wish they had an option that we could say we could turn off autosave as the default option across our entire account. Another tricky one is glue. So glue is cool in that it has automatic retries if your job fails. However, if that retry failure is due to a resource limitation in glue, it retries on the same exact, basically, worker process. So I've got 4 retries, all 4 fail. Great. So what happens next? The engineer goes in, looks at it, it's like, oh, I'm just gonna click retry. When he clicks retry, it works fine the next time. Why? Because it moved to a different host. So whatever that transient problem was, went off, and we have no insight into that. The other tricky one with glue is, and this goes back to data quality, is on date time fields, and you have a date time field, if you get a bad record in there and then you do a query against it, the whole query breaks. You can't do date time math. So we basically had to work around that by casting all our date time into strings and then reconverting them back into date time for date time math. That's pretty painful. So results, what did this give us? Well, if any of you have used Woot before, there's a thing we sell called a bag of crap. It's very popular. It shows up out of nowhere, and our users like to say it's like magic. Well, QuickSight, Athena, Glue, Lambda, by using AWS, they give us magic features. Lambda has gone from 5 minutes to 15-minute runtime. We have twice as many graph options in QuickSight as we used to. We now have metric math and machine learning in QuickSight. QuickSight and Athena have increased the amount of rows of data they export. It used to be 25,000, now I think it's 1 million. It really you just get it for free. No upgrades, nothing. That makes our lives so much easier. The other thing, performance. Since moving to this, we have been able to scale horizontally without breaking anything. In Karthik's story, he talked about how one user ran a bad query and it blew up the whole data warehouse. That doesn't happen anymore. One query goes bad, that's just that worker. It doesn't break anything anymore. We don't have to worry about resource limits on our main database core and cluster. It just scales out. The other thing is nobody could actually quite quantify it, but everyone said they were simply amazed by how much faster their queries are. We didn't quite, all the queries and everything were rewritten, so we didn't have an apples-to-apples comparison, but basically all our queries for end users were returning in seconds instead of closer to a minute. AWS integrated. I mentioned this a lot of times, it's a recurring theme. By having AWS, it worked with everything our developers are familiar with. We can add a new data set in literally minutes. It only takes us a few minutes to go ahead and spin one up, especially since we have CloudFormation documents. Just put in the new parameters, deploy it out. We've got a new data set. We have a new data pipeline. It used to take days and weeks to do that, depending on the complexity of the new system. Ease of use. I mentioned this before, but the single logon by our customers is one of their favorite things. They don't have to remember some database login credentials and figure out when that changes. It's just their normal password and their normal password reset time. And if they're on the network, they can single sign on. And then QuickSight. So this is the first time at Woot that we actually had our CEO log in to view a dashboard. Before, he would only view the reports that were sent to him. So that's how easy it is. He actually uses it. He actually dives into it. And it helps him do his job and make decisions faster. Flexibility. So one of the things is, again, is this whole platform is language and schema agnostic. We now are starting to use Rust, .NET Core, Go, Node.js. We have Java, JavaScript, .NET, Python. I'm sure I've missed some others. They all work. Before, it was always kind of touch and go on what you had to use and what had a driver that would work with it. So some data points. Since we launched this about 2 years ago, we had about 12 terabytes total of data warehouse data. And this is Woot's data, by the way. We consume a lot from other places, but this is just our core business data. We now have 60 terabytes total. Yes, some of that is our raw data. And because, as I talked about, we have the raw data, and then we transform it. But about 80% of that data is our new data. There's no way we would have been able to scale to this without a data lake. I mean, the cluster cost alone on our old data warehouse would have killed us. So I mentioned we use QuickSight. We automated all of our weekly business reports, which used to take 40 hours across all the business units. We saved an entire person through this process. And then the other fun one, and this is even after all the data expansion, we've seen a 90% reduction in costs from licensing and cluster costs by using this system. Also before, we had a single kind of cluster running in one VPC. It was really challenging and hard to secure and make sure our connections were right across VPCs for this. Now that we have this, we've gone from one AWS account to 8 with it takes about half a day to add another account to it, depending on what the parameters are of that account. And we plan on about doubling that in the next year. The other thing is, as I mentioned for our deal evaluation, we now run through 600 million distinct rows of data calculated weekly. That is many multiples more than our entire legacy system would do in a day, or sorry, in a week. So it does a lot more scale for us. And most importantly, our Woot monkey, our mascot, was not harmed once during creating this. So what I want to do is say thank you very much for taking the time to listen to Karthik and I. We really appreciate everything. And thank you very much. And so I'm going to bring Karthik back up here. And what we're going to do is it's Q&A time. And while we're doing Q&A, first, I got to tell you about all the awesome training and resources you have. Make sure you check them out. I will say I've been to reInvent multiple times, and this is the conference out of all I've been to where I've learned the most that I can apply at my job. So as we do Q&A, here's our contact info, and we also happen to have a special gift for everybody here. We have Woot monkeys. So you can harm them or not harm them as you wish, but come on up.
Thanks, guys. Thank you. I appreciate your time.
And don't forget to fill out the survey.
Yep.